So next we would go with Jean Taillon of ANDRITZ. ANDRITZ. So
Yeah.
on biomass gasification for advanced biofuels by ANDRITZ Biomass.
Yeah, I share my screen now, so you can. The famous question. You see my screen now.
Yeah,
right?
we see it. Yeah, looks beautiful.
Okay. Warm welcome to everyone. Yeah, my name is Jean Taillon. I'm Canadian, but I've been living in Finland for many years. And basically, my task is to head. I'm leading the efforts, ANDRITZ efforts in biomass gasification for advanced biofuel. So this is that type of presentation that I do today. Next slide. Okay, so I will talk 2 slides about ANDRITZ. Then I have 3-4 slides about these biofuel pathways, some of them, and then what we can offer, what we have done in the past, so the references. ANDRITZ is a pretty large company. The revenues from half of this year were up to 4 billion euros and EBIT some 8%. And we're kind of shy of 30,000 people, employees around the world, operating in 40 countries. One of the key the message from the management or the board is really much on the decarbonization and finding solutions, sustainable solutions and products. And the one that I will be talking today is really referring to the clean fuels, so technologies to replace fossil fuels with renewable fuels. And as an example, what can be done is gasification to produce advanced biofuel. And in Europe, the definition of advanced biofuels are fuels which are produced from specific waste and reduce feedstock. So this is the application what we're going to talk about today. So there are basically 3 pathways to do this, these advanced biofuel. And these advanced, if you look on the right side, these advanced biofuel, they could be for gasoline, diesel, aviation fuels, which would be done with the Fischer-Tropsch synthesis. Synthetic natural gas would be the methanation synthesis, or then methanol, biomethanol with this methanol synthesis. So those would be called advanced biofuel. And the conventional way of that was at least studied many times, and there's a few plants existing, are with this biomass liquid with gasification. So we would receive the woody biomass, which ANDRITZ can supply, but that's not the key issue here. So the gasification plant is the technology that we offer is called oxygen-blown bubbling fluidized bed, otherwise called BFB. So oxygen-blown BFB pressurized gasification with gas cleaning. And the fuel comes, and then we have to take care of the fuel. So it's called the fuel feeding. It's with what we call lock uppers, so it's pressurized fuel feeding, bed material feeding. Bed material means that when you receive this woody biomass, it has to be fluidized, and to help this fluidization, you need another type of material. We call this bed material. Gasifier system is the reactor. So reactors are pressure steel vessels with refractory line inside. Temperature is about 800 Celsius, but then the outside should be 60 degrees Celsius. So you need some refractory. There's a reactor, there's a cyclone, there's a gas duct. Then you have these ash removal systems, and then also we need some other like distribution systems. So oxygen is needed, nitrogen is needed, CO2 is needed, and steam is also needed. And all sort of auxiliaries for instrumentation and air and so on. So that would be the gasification plant. When we go to the gas cleaning portion, then we go with what we call the tar reforming. So we use a catalyst. So tar catalyst reforming is done. Then we go to a gas cooler and then a gas filter, which is about 500 degrees Celsius. And then depending on the cases and what is the end application, you could have this water gas shift. And then we will also have a scrubber, water scrubber, to have, at the end of the day, a dry and clean syngas that is composed of CO, CO2, and a bit of methane and hydrogen. So that is the basic biomass to liquid pathway to produce advanced biofuel. What can also be done is what has been discussed quite a bit in this presentation or conference so far would be with an electrolyzer. I will not talk about that, but this is a possible way of doing things. You have electrolyzer that will need water, you also that will produce hydrogen, and then you have this carbon capture which will provide the carbon to make these type of fuels. And in these cases, it's called RFNBO, the long name that the EU has invented. So it's renewable fuels of non-biological origins. And if they are done in this pathway, that's the name they have. And then the common name that people use often is called e-fuels. So for example, when you do methanol, then you would call this e-methanol. Whereas in the previous case with the biomass, it was called biomethanol. ANDRITZ can supply the electrolyzer. We do this, but again, this is not the focus of my presentation. Then the third way would be to combine these two technologies or these two pathways together. So we will still have the gasification on the top. But then what's happening is with this type of technology, the biomass and these synthesis, you don't have enough hydrogen to have the full use of carbon. There's not enough hydrogen. So by combining these electrolyzers to give this extra hydrogen, then we can pretty much have 100% or a very high carbon yield in these products. So you can increase the production. So this is one way of doing these advanced biofuel. And having said that, if you would choose this pathway, then it would be called advanced biofuel. And then in the case of methanol, then it would be called bio-e-methanol. We should have certain discipline on these namings. So these namings are quite important when they are for funding or subsidies with EU. So this is the the third pathway. And then the next slide is really between these three pathways. The BTL, so advanced biofuel. So not all carbon will be used in the final product because these type of synthesis will have a CO2 emission because there's not enough hydrogen for these chemical reaction. So there will be some carbon loss as a CO2 emission. But it's a simpler technology. And I'm saying this because I'm now comparing with this electrolyzer. It's a simpler technology of these three. This is the simplest technology. It will have a lower capex and also a lower opex. So there's plus and minuses. The P2X, well, not every country has biomass. That's the only thing I could say about that. And then if you have this PBTL, then comparing to the first one, the biomass to liquid, we can then have now this higher carbon yield, so more biofuel can be produced. Again, comparing to the biomass to liquid, then the capex also increase. Electrolyzers are not so cheap, and also the price of electricity is not so cheap either. So both capex and opex will be higher. Compared to the PTX, the electrolyzer in this concept, this PBTL, will be less. So the electrolyzer capacity, we say megawatt electrical. So in the P2X, it will have, let's say we take an example, it would be 200 megawatt electrical capacity. But then if you go to PBTL, then it's something like 30% less hydrogen is required. So it would be maybe 150 megawatt electrical. So there's a lower megawatt electrical required, and then the OPEX of these electrolyzers are not so, or they're quite substantial, so they will be lower OPEX in that sense. The other clear benefit with the electrolyzer is that one of the output is oxygen, and we need oxygen on the gasification. So that is a good mix. They always produce an excess of oxygen, much less that we require. So this is good in that sense. ANDRITZ can provide all these pathways. So it's really up to the customers, the location where they are, the financing, and what you want to do. We have no preference in that sense. The last slide is what do we have in terms of gasification? So we offer both this pressurized BFB, as I explained, and also this atmospheric CFB gasification. From the BFB side, it's this picture that you see on the right that comes from Skive. Skive is located in Denmark. It's a CHP power plant that is based on gasification. It's an air-blown pressurized BFB that is sending a clean syngas to 3 gas engine, Jan Bayer that just spoke recently. I might be subjective, but I think it's one of the biggest CHP power plant based on gasification. It's running still today. It started in 2007, and yeah, it's a very good plant in that sense. And having this as a reference, it has really gave them the signal to the investors that this is kind of a proven technology. What you see there on the picture, the size of this reactor, you can have an idea of the size. This would be, if we say here 20 megawatt fuel, that will give you the size. But when we are talking about this type of advanced biofuel, it is large capacities. Typically, would say maybe 100 megawatt thermal, 150 megawatt thermal. And the size of this reactor will be exactly the same size as you see now. So this is for us, Steve, a very good reference. It's a good reference because of this pressurized has been proven working over there. And from the size point of view, it's what you see at the moment. But then when we did Skive, this was air-blown, so we needed to have extensive pilot testing for this oxygen-blown type of concept. You want to go with oxygen, so if you use air, you have nitrogen. And in this advanced biofuel, if you have nitrogen, then you have to get rid of this nitrogen somehow. It increases the flow for nothing, so oxygen is the oxidant that is used with some steam, of course. So extensive test campaigns has been done. This can be found in the internet. They were done with UPM and E.ON project in Sweden. So they were done for biodiesel type of testing, synthetic natural gas, gasoline testing was done. What you see there in the picture in the middle down was it's a wooden pellet that was done at this testing facility, and that is the end product, the gasoline that was done, which was quite acceptable to the standard qualities to be blended in gasoline. And those tests were done with oxygen-blown pressurized BFB. But we should not also forget that we have certain expertise in gasification and quite active on the CFB market, which is ANDRITZ is a very strong presence in the pulping industry. Pulping industry have the largest heat demand comes from the lime kiln, the weTHINK plant, the lime kiln. And very often nowadays we will have a gasification plant feeding the lime kiln burner to provide the heat. So what you see in the picture down there is one of these plants in China. This one is 60 megawatts. So we have in operation 4 plants, 50 to 80 megawatt thermal, and ongoing project, 3 plants, 60 to 115 megawatt. 150 megawatt is the largest, will be the largest CFB gasification plant in the world. So it was a big order for us, and that will start up quite soon this year or next year. This was my last slide, very short presentation, but I wish there'll be some question about that. But yeah, and I will stop here, Ingo. Thank you very much. Thanks.